Now gents, I've got a fellow YouTuber who is, and ladies, I've got a fellow YouTuber who is tearing his hair out with a systematic reset power supply, so I thought I would try and explain it a little bit. So he's having a couple of problems. One, reset's stuck low all the time, and this LED's stuck on. And he's took this out, and it's still stuck low. He's took this transistor out, it's still stuck low. I think he's got a problem with the power supply. There's a reset circuit inside the power supply, but we'll get back to that. Also, thing he's trying to say is, he says he's tearing his hair out trying to follow a schematic. So I thought, I'll try and explain it best I can. Now, it's like Eminem here, I'm trying to explain it, but the words won't come out of my mouth right, so this is the... I've tried several times to get this video, can't do it. So I'm just going to leave the mistakes in this time, so I'm going to try. So, let's try and go through it a bit of time. ZTX 450 transistor here. And then Q82, and then you've got a ZTX 550 there, Q84. Actually, two reset transistors. This was in PNP, which means you send a high signal to turn it off. And this one's an NPN, which means you send a high signal to turn it on. Right? With me so far? These two diodes here play a vital role in how this can all work. You basically separate this into sections. So, I'll go through the sections. You got your power on reset here, half of which is in the power supply, the rest of it's up here. You have a missing pulse detector which is formed here. This counter on this gate with some wire links, and you have a watchdog timer, which is here. And a couple of other capacitors and that, but we won't go into too much detail on those. We'll try and keep it simple. So, let's say you power the machine up, but there's no power on reset. So what will happen is, this LED will turn on. This will drop low because you're charging this capacitor, which means this is getting pulled here. In a few seconds, and your board will be in reset. You'll be stuck in reset. A couple of seconds later, you'll have charged this capacitor and it will start blocking the level. And then this pull-up resistor takes over here and it pulls reset up to 5 volt. Okay? Now, if the power on reset's working, when you turn the machine on, a circuit inside the power supply will send 5 volt up here through this diode. Now none of this will matter in a minute because this diode is blocking anything that comes through here. Voltage truth down here and down to the Q82 here. Because it's an NPN transistor, high level, turns it on. That then creates a direct path to ground, direct path to 0 volts. Takes that out of the game. Current flows down there, and through there. And it pulls that low. Okay? That's your power on reset. Once the voltage is and everything is stable in the power supply, this is removed. This turns off. And then we get the same situation as though this hasn't happened. This simply charges up. And then this goes high because it's getting blocked through here. Reset line's getting pulled up to 5 volt by this resistor. And current can't flow through down through this LED, through this capacitor because it's blocking it and it turns the LED off. Okay? So, your board's working away now. So now the next two parts come into play. This goes low, by the way, which means that this is now blocking anything coming this way. Right? Okay. So, now this goes into play. Remember, this is a PNP, which means the high signal here turned it off. Okay? So we've got IC20 here, which is a 555 timer, just like the other one over here, which is IC27. Haven't spoken about that now, but we will. So, with a 555 timer, you give it a low trigger signal, and this is called a one-shot setup. The setup it's in, you get a high pulse out for a certain amount of time, and then it turns off. It goes back low, okay? So, what you're doing with this is you just want to keep the output high all the time. So you basically want to keep re-triggering the timer all the time, so it never timed out and that never goes low, okay? So what you do is you send it a pulse through one of the outputs on the board. There it's there. The game will constantly be setting the pulsing this line, which constantly pulses this watchdog signal into the trigger of this 555. Pin 2 is the trigger. There's your time base there, by the way, that resistor and that capacitor, but don't worry about that. So you're constantly resetting this timer, so that's always going to be high. When you first trigger a 555, the output is high. Pin 7 will be high. And it's always going to stay high. Right? You with me? It's actually not. It's been used as the output, but I know the people who know 555s will go, hold on a minute, that's not the output pin, the output pin's there. Well, this is the genius of JPM. They're using the chip and they're using the 555 timer in a strange way. But the principle's the same. But we don't need to go into that level of detail. I'll explain that more at a later stage. So basically, right, you're resetting this timer over and over and over and over again. And this pin 7 here is being held. So this is always being held high. Now, say it times out. Okay? It times out and this goes low. Well, what's then going to happen is, if you know your electronics, pins can sink voltage as well as send it out. So what's going to happen? Sink current as well as send it out. So what will happen when this goes low is the voltage will go down through here, through this capacitor and into there. That, because you got a path through here, pulls the power away from there and turns it off. Turns it on, sorry. The base of it goes to low and it turns it on. So reset pulls low. But it's not going to do that forever because of this capacitor here. So after a short space of time, this capacitor is charged up and blocks this signal here. See? So then, this 5 volt is then pulling back through here and turns it off. Remember, it's a PNP. It needs low there to turn it on, close to 0 volts to turn it on, and high signal to turn off. It's actually about 0.6 volt, but by the time you go through this resistor, you get 5 volt through this resistor down here and turns it off. Okay? It's the important thing you need to remember. Always remember that with a PNP, you're sending a high logic signal to turn it off. With an NPN, you send a high logic signal to turn it on. Okay? With me so far? Right, so once this capacitor is charged up and this is flowing back through here, reset signal is cut off from ground. Okay? So then the reset line goes back to high because it's pulled through here again. See? If you imagine that transistor over there is being here and pulling that straight to no volt. Probably easier if they actually drew it there, but never mind. Okay, so that's how the watchdog works. Now we've got another piece of the puzzle to deal with. The missing pulse detector. Got two chips here. IC1 and IC22. The 74L393s, and they're just forming a binary counter. Okay? And then you've got a ZTX 450 here. And that's tied to the 100Hz sync signal coming off the power supply. Now that's just a pulse coming up from the power supply to tell it the mains voltage is there. It's unsmooth DC, it's going like this. So it's doing the equivalent of high low all the time. This capacitor, it's like analog, but this capacitor smooths it out so you get pulses going here. So that's pulsing at 100 Hz, which is just, if you know your electronics, when you rectify AC to DC, it's twice the speed that it used to be, because of when you've got a 50 Hz wave like this, when you rectify it, all the pulses are on the top, so it's running twice as fast. Again, we'll get into that at a later stage. So you've got the sync pulse from the power supply coming here at 100 Hz. 100, sorry. Scottish accent going on here. Which is turning this on and off very, very quickly. Okay? Pin 12 here is the reset for the counter. The job of this transistor here is to pull the reset line. See? It just pulls it in a path to ground. Every time you get a high pulse here, this turns on. You're just pulling the reset line low. See? Like that. At the same time, you've got clock signals here. And here. Telling the counters to count up. All they do is count up. They count up from 0 to 16 and over again. Over and over and over and over and over again. Right? And they're being pulsed by the system clock, which is coming off here. That comes from the CPU card. So there's a kind of race going on here. These are counting up very, very quickly. And this is trying to reset it at 100 Hz, 100 times a second. So the aim of this here is, they can't be allowed to count up to a certain amount before it resets. And what they do is, they've got an AND gate here, a 4-input NAND, not AND, which means that if all of the outputs are high, that goes low. If any output goes low, that's high. And what they do is, the outputs of the counter, you can link certain combinations to pull some of these low and keep this high. See how this is into the trigger of this timer? We'll get back to this in a minute. So your 100 Hz is coming in here, resetting this 100 times a second. If this can count to a combination where the connective links are high and send this low, before this can reset it, it can tell the sync pulse isn't there. Okay, because being able to count up to that value here, whatever it needs to create all high here and a low here, before it's been able to reset. You see what I mean about the race going on? You might think, well, why have they got links there? Well, It's because JPM were big in the Dutch market, so they designed this board in mind so it could run on 50 Hz, giving you 100 Hz second pulse, or the likes of 60 Hz, which would give you 120 Hz second pulse, roughly. So you have to be able to link different combinations here to determine how fast the mains pulse is going. Know what I mean? Basically, it's just a little bit of forward thinking for them. But we're in the UK, so it's 100 Hz, so I believe it's just 8 to 13 that's linked. So every time this can count up. Yeah. So when it's counting away this link, it's looking for this link to be low, which keeps this high. These are just there to make sure they stay high when they're not called for. So if this can count up faster and this can reset it, it determines the missing pulse isn't there. Okay? What then happens? This drops low. Doesn't drop low straight away. Briefly charges that capacitor and this drops low. Okay? That causes a couple of things to happen. It causes high pulse to come up here. Because you're triggering this, that goes high. This one works the opposite way of the other one. The other one you want to stay high, this one you want to stay low. So that goes high. Through here, through here, through ST48. It won't go this way because there's a low here, so it can't go through there. Current only flows in the direction of the arrow, remember. Down here, turns resets none of this are on. Pulled low, your board resets. At the same time, it helps to discharge the timer. This is just a wee bit of a help so that it doesn't get locked up. So resets for a few seconds. I believe that's determined by the C9 here. That's your timing. Then that creates 4 seconds. So this will go high for 4 seconds. Turn this on. Reset goes low for 4 seconds. Then that goes low. Turns that off. Reset back high. With me? I hope you are. I hope you are. To anybody who doesn't have a bit of basic knowledge of electronics, this is going to be gobbledygook to them. But if you're used to working in electronics and you have a basic understanding of how they work, you'll know what I'm talking about. Now, hopefully this will help. Hopefully this will help my fellow YouTuber in diagnosing the fault. Because at the minute I think that this 5 volt is here all the time. And just pulling this. I'll maybe jump on one of the forums and explain this in a bit more detail, or I'll email it to the person as well. But basically, to break it down, to troubleshoot this, the first thing you do is disconnect D48. So that only the power on reset works. Okay? Get that working so that turns that on and off. Then disconnect D50 and see if this works. You can manually trigger this just by dropping that low. So you could just connect a brief low pulse from pin 2 there, top of C10. Just short that briefly to ground and that will trigger that and test this. You could even put a reset switch in there, and there might be a way to do that in System 8 actually, but it's another time. So disconnect this, get this working first. Then disconnect this and get this working. Okay? Then lift this again. Remove these links. Tie them all to 5 volt. Leave them all tied to 5 volt and get this working. Lift the link, make sure that goes low. Put the links back, make sure that goes high. Lift the link, make sure that goes high, put the links back, make sure that goes low. You know what I'm talking about. Do it in stages. Once you've got this working, concentrate on that. Remove that transistor, make sure you can get this working. And my thumb in the way. Don't try and work on it all at the same time. Split it into sections and get each section working one at a time, okay? And if, I know the purists don't like messing with boards, but see if this was my own board. See that absolutely useless level 3 interrupt switch, which I don't know why they leave it on. Why would you want to turn the game up? I don't know. It's a software reset, okay? But what I would do with said software reset here is tie a link from the bottom of this 10K to here. So when you switch this reset off, you're actually doing a hardware reset. For testing anyway. I'll go on. The various game manuals I've got for these JPM machines, I'll talk about software resets, but I'm hoping that people fixing these can follow that a wee bit. I've tried to keep it as simple as I can, and it looks super complicated, but it's not. Most of all the extra capacitors you see there and the way it's set up are basically all to make sure that it can do its job and it can't lock up. So, well, 23 minutes. I was only expecting this to be a few minutes long, but 24 minutes long already. So, let's go back to this IC28 for a second. The purists are going to tell me that's the output and pin 7 is the discharge. And you can see that here. See it? Output, discharge. So they're going to tell me that that's a typo in the schematic. Well, it's actually not. It's actually not. Closing the name. If you were to put a logic probe here when you trigger this will be high. Okay? But the closing the name discharge. This will be discharging this capacitor. Yeah? So the effect of that is it'll pull current down through here. Just a little bit of thinking outside the box for the JPM designer. It's probably that this is more efficient than pulling current down here. Because the clue's in the name, discharge. The discharge pin is there to discharge the capacitor. That's what it's for. So they've taken advantage of that and they've tied that to here. So what's high? You discharge that and you send in. You're pulling power away from there for a short space of time through here until this capacitor is discharged. Then this path turns off and you send 5 volts to there instead. It's just a little bit forward thinking. The guy that designed this always thought outside the box, and he's probably determined that it's more efficient to pull current down through here than it is to sink it through here. And thinking about it, it is, like I say, for the third time, closing the name, discharge. Pin 7 discharges the time capacitor with the 555 so that the cycle can run again. So it's made more sense as a designer to take advantage of this capacitor discharging to pull power away from here and turn this on. PMP, remember. It also guarantees that once this is discharged, this is then blocked and this turns back off. Following it? And the rest of it you can basically ignore. You can concentrate on that once you've got the reset working. You don't need to worry about this. This is to do with interrupts. Don't worry too much about that down there. That's to do with address decoding. That, don't need to worry about either. You can simulate conditions here. Because you're not looking for the board running at the minute. You're just looking for the reset sections working. So, like I said before, sections at a time. Concentrate on power on reset first. Then do missing pulse. Then do watchdog. Okay? And I'll be on hand to help the YouTuber. I'll be on hand to walk him through it. So, if you like this video, then would you like me to do more explanation videos and get even more confused? Leave a comments below if you want any more videos on, like, you want any more explanation about that pure oscillator or how switch matrix work, because a lot of people get confused when you're looking at a switch matrix schematic. Basically what I find all the time is people get confused by the likes of these. They know that current can only flow one way through a diode, but then they see the diode pointing backwards and opposing the flow of current, etc. Or they get confused by electrolytic capacitors seeming to be backwards in the circuit. There's a reason they've done everything. And I think what a lot of people do is they overthink it and they get themselves confused. But anyway, if you like some more videos like this, leave a comment. If you don't, leave a comment. If I confused the hell out of you, leave a comment. Any criticism is good criticism. I'm good at troubleshooting, but I'm not always good at explaining what I'm doing. I'm sometimes too technical. But I'll get better with time. I'd just like to say thanks to the wonderful Mecha members back in the day that uploaded this in the first place. Because until we had this, we're here to work our backside trying to troubleshoot these because we're having to do it a chip at a time. And I know, I just hope things like the MPU Mecha and everything, Fruit.emu, Diff, The Excellent, all places like that continue, because I know a lot of the community is moving on to like Facebook and that now, but we still need to keep our old forums going. They're an invaluable resource, and if we don't keep contributing to them, they'll die, basically. I've got something in mind that I'd like to do in the forums at some point. It's just basically getting time to do it. But anyways, this has went on way longer than I thought. But I hope you can make use of it. And when the YouTuber in question gets a hold of me, we'll make a start. Okay. Bye bye for now.